Guys, welcome back to the weekly live stream from Scalar Learning, where we cover SAT problems straight from the source, straight from Khan Academy. And we're going to do 5 SAT math problems today, focusing on circle theorems problems. Now, first things first, I know that I do this weekly live stream every Wednesday. And by the way, if you are prepping for the upcoming SAT and want all that good help, make sure to subscribe right now so you get weekly updates and new tips and tricks on the regular. But I was supposed to do it last Wednesday, and I didn't, just to let you know why. I was very sick, so I apologize for missing that live stream. But we're back in business today. Here we go, circle theorem problems. Let's do it. As always, I'm doing these problems for the first time, so that's part of the fun. We'll see what happens. First question, the sector of a circle. Sector is like a pizza slice, so this big chunk here, shown at the left, has its center point at A. The length of AC is 8. Okay, so you know what I'm going to do, just because a lot of times with these diagrams, so we can see everything at once and I can mark it up, I'm going to put it up over here. So we got this guy, nice and big. All right, the length of AC is 8, so they got that in there for us. The line segments AD and BC are perpendicular, AD and BC, right? These guys are perpendicular, that's the right angle, and intersect at E such that DE is 1. What is the length of BC? So we need to find this length right here, BC. Okay. So let's think about how we can do this. Now, I know that if this is the sector of a circle, right, that means AC, AD, and AB, they're all 8. These guys all have a length of 8. Okay. So I know that this whole thing has a length of 8. Oh, wait a minute, and we want BC. Okay, so that means that AE, if this little guy right here is 1, and this entire thing has got to be 8, because it's also a radius, right? All radii are equal of a circle. So that whole thing is 8. That means AE is 7. All right, so that helps us a little bit more. Again, we're trying to find this length right here. Okay. Now let's see what else we can deduce here about that right angle. Do I know anything? I'm trying to figure out if I know that this is an equilateral triangle. Because if it is, then BC is 8. So let's see what else I can deduce. Those are perpendicular. That makes a right angle. Okay. Well, we can use Pythagorean's theorem. So basically, I have a right triangle here. I have 8, 7, and then this missing side is x. And this is going to be the same length too over here, which is also x. These two triangles are equivalent. So let's go ahead and use Pythagorean's theorem, and we'll say that x squared plus 7 squared, that's leg squared plus leg squared, equals hypotenuse squared, 8 squared. And we can solve for this. X squared plus 49 equals 64. I'm going to subtract 49, and then x squared equals 15. So x equals the square root of 15. So that's this value, and then this value is also square root of 15. Therefore, this entire value here is 2 square root of 15. Okay, sweet, correct. Next question. I'm going to do the same thing. I'm going to copy and paste this. Okay. The sector of a circle shown at left as center O. Here's O. Radius OW. This is OW, so this comes out. So it's like our circle, if we were to draw it, would be something like this. Okay, it's terrible drawing, but you get my point. It's a big circle, part of a big circle. Radius OW is perpendicular. So this is a radius perpendicular to XY, which we can see here by that right angle. And intersects XY at point Z, right? There's point Z. The length of WZ is 9, as they indicate. And the length of XZ here is 12. What is the radius of the circle? So in this case, we're trying to find this value right there. So that's the radius, and we need to know what that radius is. So let's try and figure out, or let's try and see how we can figure this out. So I know that, oh, and this is also the radius here. by the way. And this is the radius. So these are all these values are equal. So let's see if we can get an idea on how to do this. Now, again, I can see that I think Pythagorean's theorem is going to be a nice option in this case. The way that I can see that is if this is an entire radius, right? That means, so this whole value here is r, right? That means that this little value right here is r, but it's minus 9. So we take 9 away from the radius, and that's what this value is here. Now I think we can use Pythagorean's theorem. I don't know if this is the easiest way, but this is the first way that's coming into my mind. Is we can use Pythagorean's theorem with this guy, this length, so we can kind of isolate this triangle here. Let me show you. Like that. Okay. So I can use this, and using these three values, I should be able to calculate the value of r. So let me show you how to do it. So r is the hypotenuse, right? So we have leg squared plus leg squared equals hypotenuse squared. So 12 squared plus r minus 9 squared equals r squared. So if I'm going to FOIL this, well, first, that squared is 144. Plus this FOILed is r squared. So that's like r minus 9 times r minus 9, where we're going to FOIL, right? Like that. So r times r is r squared. Negative 9r makes negative 18r. And then negative 9 times negative 9 is plus 81. All right. These guys combine. 144 plus 81 is 225. R squared minus 18r plus 225 equals r squared. These guys will cancel out, subtract r squared from both sides. Okay, then I have negative 18r equals, I'm gonna subtract 225 from both sides to isolate r. So we have negative 225. And then I'm gonna divide both sides by negative 18. And we should get our answer. Oh, it's a no calculator question to the nearest tenth, so we got to do that division. So that's just basically 225 divided by 18. 18 goes into 22 once. Bring down the 5. That goes in twice. That's 36. 45 minus 36 is 9. Bring down the 0. And that's 5, so it's 12.5. Let's see if that's right. That seems to make sense. That means this value is 3.5. Let's see if that is correct. Yes. All right, sweet. I'm going to take a quick screenshot of this guy. Okay, semicircle at the left shown has its center at point O. The diameter of the circle is 30, so that this whole length is 30. And the arc, this is the arc length here, is y, x, z. It's a length of 18. So they actually didn't put that in the drawing, so I'm going to add that. This whole arc length here is 18. To the nearest hundredth of a radian, and this is no calculator, so it's pretty tough. To the nearest hundredth of a radian, what is the measure A? What is the measure of angle YOZ? So we need to find this. Okay, let's see here. So the diameter of the circle is 30, and we need this value. And that, oh, and they're telling us this is 18. So let's see how I can do this. Oh, I know how to do this. Okay, so first let's calculate the circumference if this were an entire circle. So the entire circle circumference would be diameter times pi, which is 30 pi. Okay, so that it's just diameter times pi. So that would be the entire circle. And then we just want, and then if we want to calculate an arc length, what we do is we take angle A over, in this case is radians, so it's not degrees, it's radians. So a over 2 pi, which would be like the angle over 360. We're basically taking a fraction of this little angle over 360 because 360 is the whole. 360 is going all the way around the circle, the complete circle. So a over 2 pi, we multiply that times the entire circumference, and we get our missing the arc length, which we know in this case was 18. Because remember, we're trying to solve for the angle. And now we solve, and now I see why you don't need a calculator. So the pi's cancel out, and then this becomes 30a over 2 equals 18, which just becomes 15a equal, 18 equals 18. And then we divide both sides by 15. And we get to the nearest hundredth, a equals, that reduces to 6 over 5, because we're dividing top and bottom by 3. So that's 1 1/5, which is actually 1.20. I think that's right. I don't know why they say the nearest hundredth. Let's make sure that's right. To the nearest hundredth of a radian, what is the measure of angle A? Should be 1.20 unless I've done something wrong. 30, 40, 30, 36. I think that's right. Yes, sweet. Okay. Next. 2 more. Oh, whoops. There we go. The sector of a circle shown at left has center O. The radius of the circle has length 5. The arc XZY has length of 7. So this whole thing here. Has length of 7. To the nearest tenth, what is the shaded area of the sector? All right. All we got to do here is, oh, wait a minute. What is the shaded area of the sector? Okay, I know what we have to do. We have to figure out, this is a bit of a harder question. We actually need to know this angle. Because to calculate the area of a circle sector, we need to know the area, first we need to know the area of the full circle, and then we need to multiply that by the value of this angle over like 360 or 2 pi or whatever it is. So let's figure that out. Now I actually think this might be easier if we do this in radians, but you could do it in degrees too, it doesn't matter. Okay, so first of all, I'm going to say the area of the entire circle is pi r squared, right? So pi r squared. In this case, radius is 5, so it's 5 squared is 25 pi. So that's the area of the whole thing. And then we also need to know the entire, circumference. We have to work backwards, to solve for this. So first, before we do area, I jumped the gun. We need to do circumference. So that's 2 pi r. So this is also here. So 2 times 5 is 10 pi. So the entire circumference is 10 pi. So 10 pi times theta over 2 pi equals 7. Cross off the pi's, and 10 divided by 2, we get 5 theta equals 7. So this theta is 7/5. Remember, that's in radians. So that's like approximately maybe 100, no, what is that? 1.2 and then 6. So it's like maybe 60 degrees, something like that, I'm guessing. Okay, so now we've got 7/5 radians. Now we use that for this. So we say we take the area of the entire circle and we multiply it again by 7/5 over 2 pi. This angle over 360 degrees, or in radians, 2 pi. And what does that equal? Let's solve. So these cancel out. 25 times 7/5 over 2. This reduces to 1 and 5. 5 times 7 is 35 over 2. which gives us 17.5. So 17.5 should be the right answer. Yes. Okay, so that I would classify that problem as actually very hard, or like in between medium and hard. Okay, next. The sector of a circle shown at left has its center at point O. The radius of OX is 8, and the area of this entire sector is 120. Oops. To the nearest hundredth of a radian, what is the measure of A? What is the measure A of central angle XOY? So we need this angle. All right, so let's see. So it's the same idea. It's the same idea. So first of all, what's the area of the entire circle? That's the first thing we have to calculate. That's by pi r squared, where 8 is radius. So that is pi times 8 squared, which is 64 pi. So that's the area of the entire thing. Now, to calculate the area of a sector, we use that formula. It's the angle A over 2 pi. I'm again using radians. I could have put 360. I'm just choosing to do this. And oh no, actually I need it to be in radians. It's asking for radians. So 8 over 2 pi times the entire area equals my sector area, which we already know is 120. And then now we solve for A. Pi's cancel out. 64 divided by 2 is 32A equals 120. Divide both sides by 32. This is the same as 60 over 16, which is the same as 30 over 8, which is the same as 15 over 4. So that I can do in my head. 15 over 4 is 3 3/4, which is 3.75. And we can think about this for a second. Does that make sense? So again, halfway around would be 3.14 because that's pi, and pi is like 180. 3/4 of the way around is pi and a half, which it would be about 4.6 or 4.7. So this actually seems too small because this would be like 4.7 here. So this seems like it should be closer to 4.2. You know, right in the middle maybe would be 4.5, would be 3.75. That doesn't seem right, or this drawing is not to scale. So let me check my numbers really quickly to make sure I did this correctly. So 64 pi times A over 2 pi, right, equals 120. We know that's correct. So the radius OX of the circular sector is 8. Yeah, okay. So then it's 32A. So it's 120 divided by 32. Let's just try the original thing here. So this is 3, 4 is 120. So it's 3 is 96, yeah. 4 and 0, 11 is 2, 240. 210, 224, and then that's 16, and then that's 5. So it is 3.75. All right, I think my math is right. Let's see if it's correct. Yeah, so I just think this drawing is not to scale. So that's it for the weekly live stream from Scalar Learning on SAT Khan Academy math problems. Again, if you are prepping for the upcoming SAT and you want all the best tips and tricks for the math section of the SAT, make sure to subscribe. We do weekly live streams, again, every Wednesday. And if you like this video, found it helpful, make sure to click that like button. It really helps out the channel. And if you have additional questions, put those questions in the comment section. I try to answer every single question that students throw at me if something is not clear in my explanation. Thank you guys so much, and I'll see you all next time. Take it easy.